Most of the matter that we see around is made up of atoms. In turn, atoms themselves are made up of positively charged nuclei, which majorly consist of protons, which are positively charged, and neutrons, which are neutral charged. And we have the negatively charged electrons forming a cloud around the nucleus. The number of protons in the nuclei are equal to the number of electrons orbiting around them, and hence atoms generally are neutral. Hence, as most material are made up of atoms, they are also neutral. But if you were to rub one material against another, in some circumstances you would notice that electrons from one of the material get transferred to the other because of the force of friction, hence making the donor of electrons positively charged, while the material which gains the electron becomes negatively charged. This process of charging is known as charging due to friction. You would have noticed that when you rub a plastic comb or a plastic rod against your hair and bring it near pieces of paper, small pieces of paper attract to the plastic rod or the plastic comb. We are aware that opposite charges attract, but in this case, only the rod is charged, while the paper is chargeless. So why does this attraction take place? Let us take a look. Let us charge a rod by rubbing it against another material. In this case, the rod has acquired a positive charge. If you bring this rod near an uncharged material, electrons in the material will be attracted towards the positively charged rod, leaving behind partial positive charge from where they have left. This causes a partial positive and a partial negative charge to be created in the material, and hence the material now will be attracted to the positively charged rod. Similarly, if you have a negatively charged rod and you bring it again near an uncharged material, in this case, electrons in the material will repel from the negatively charged rod, leaving behind a partial positive charge. It will then attract to the negatively charged rod. This is known as induced charge. Once you take the rod away, the electrons go back to their original position and the material becomes neutral again. Hence, the charge is not permanent. If I were to ask you a question, what is easier to charge, a conductor or an insulator? You might be tempted to answer a conductor, but it is an insulator which will be easily charged. The reason being, it does not allow the charge to flow through it. On the other hand, it is very difficult to hold charge in a conductor because it allows charge to flow through it. So how do we charge a conducting material? Let us take a look. Here you see a metal sphere separated by an insulating rod. You connect a wire from the sphere to the ground. Then you bring a charged rod. In this case, it's the negatively charged rod, because of which electrons are repelled back and via the electrical wire they flow into the ground. Now you take the wire away, so there's no path left for the electrons to come back into the sphere. And then you take the rod away. The charge on the sphere will now evenly distribute itself. And because there is no path for electrons to come back, the sphere remains charged. This is known as charging due to induction. This is the method used to charge conductors, as touching or using friction to charge spheres is an ineffective manner of charging, as conductors conduct charge away.